In this video of set operations, I will talk about two operations called disjoint and difference between sets. So the first concept is disjoint between two sets. By definition, disjoints between two sets A and B is that A and B are disjoint if they have no common element. So the notations of this is that A intersect with B going to give you an empty set, or the empty set can be written as this. In terms of the Venn diagram, you can start again with the universal set, and you have set A and set B, and you can say that the intersection between these two sets will give you the empty set. So in this case, I want to say that A intersect with B give you an empty set. So there's no element between A and B. In addition to this type of Venn diagram, I can also use this Venn diagram to illustrate that there's no common elements between A and B, therefore A and B are disjoint. Let's consider the following example. Consider two sets. Set A is the set consists of the element 1, 4, 5, and B is the set consists of the element 2 and 6. By visual examinations, you can see that there's no elements that are both in A and in B. So we say that A and B are disjoint. Or you can illustrate this answer as A intersect with B, give you an empty set. Now, in terms of the Venn diagram, you can start with the universal set. You have set A, and you have set B. In set A consists of the element of 1, 4, and 5. And in set B consists of the element of 2 and 6. And there is no common element between A and B. So therefore, you conclude again that A intersect with B give you the empty set. Now, I'm going to move on to the next set operation. It's called difference between two sets. By definition, the difference between two sets is the set of the elements that are in A but not in B. In terms of the notation, you can either use A minus B, or you can use A backslash B. Either notation should be fine in set operations. In terms of the set builder notations, you have that the difference between two sets is the set of the element x, such that x is the element of A and x is not the element of B. In terms of the Venn diagram, you have set A and you have set B. And to visualize A subtract B, or A backslash B, we only going to shade the area where the element is in A only and is not in B. So the area that's shaded in green is the area of the difference between A and B. Now, when there's a difference between B and A, what it means is that you want to find the set such that the element is in B and that element is not in A. In that case, you can change the area that is only in B. So this area shaded in red is indicate that this is B minus A, or B backslash A. This shaded area in green is going to give you A minus B, or A backslash B. And we can get rid of this caption. Next, let's consider the following example. So you have the set A to be 1, 3, 5, and the set B is that going to be 4, 5, and 6. So let's do some set operations here, including the union between these two sets, the intersection between these two sets, the difference between the two sets. So you have A union with B is going to be 1, 3, 4, 5, and 6. The intersection between these two sets, so you find the common value between these two sets, which is the element 5. So the answer is that the intersection is the set of the element 5 only. Now you want to find A minus b, or the element set in A but not in B, we see that the common element between these two sets is 5. So therefore, you're going to get rid, therefore you go to the set A, get rid of 5, and you get the set of 1 and 3. So this set include the elements that in A but not in B. If you want to do B minus A, again, the intersection between the two sets is 5, then you go to B, you get rid of this element, and you arrive at the set of 4 and 6. So this the set consists of the elements that is in B but not in A. So by illustrate this example, we can see that in general, the difference between A and B is different from the difference between B and A. So be careful with that. Now we're going to consider the last example here. Let's consider something more complicated. Let's consider two sets, the set of all rational numbers and the set of real numbers. So the set of all rational number is fancy Q, and the set of all real number is fancy R. So the union between these two sets is going to be the entire real line. That gives me the set of all real numbers. The intersection between these two sets is going to be the set of all rational numbers only. Now if you take rational number and you get rid of real number, the answer should be the empty set, because so the set of rational number is a subset of real numbers. By getting rid of the entire real numbers, you're going to arrive at the empty set only. But when you take the real numbers and you subtract or you get rid of the rational numbers, what remaining in the set is going to be the set of all irrational numbers. So the next concept I want to cover is called complement. By definition, a complement of a set is the collections of elements in the universal set U that are not in the set A. For notations of complement is that you can use 8 with the superscript C to indicate that you want to find the complement of the set A, or you can write A with the bar on top of it. Either notation should be fine. Now in terms of the set builder notation, you can write A complement equal to the set of all the element X such that X is in the universal set and X is not an element of A. In terms of the Venn diagram, so you're going to start out with the universal set. And here is set A. So the complement of A is the area that is outside of A. So as you can see, the shaded area in red is the complement of A. So you can write A with the bar on top of it, or you can write A superscript C. Let's consider the following example. You want to define the universal set as the set of all natural number. So this is the fancy notation for the set of all natural number. Then I'm going to consider the set A, where A consists of the elements of 1, 2, 3, 4, and 5. And I'm going to consider another set B is the set of even natural numbers. That is the set of 2, 4, 6, 8, so on and so forth. Now if you want to find the complement of A, you can write this is equal to the universal set, subtract A, or you can say that the natural number, subtract A, that is inside the natural number, you're going to get rid of the number 1, 2, 3, 4, and 5. Therefore, the complement of A is going to be the set that starts with number 6, 7, 8, 9, so on and so forth. Now, in terms of complement of B, so you want to find the set that is, so you want to find the set where the element is in the universal set but not in the set B. So this is equal to the universal set minus B, or the natural number set minus B. So in this case, you want to get rid of all even natural number, which is the set B, because you get rid of all the even natural numbers. What you have left is all odd natural numbers. And therefore, this set is going to be equal to 1, 3, 5, 7, so on and so forth. So this is the set of all odd natural numbers. Let's consider another example. That is, if you consider the set A of all the English vowel of A, E, I, O, U, you can find the complement of A. That is, you want to take the universal set. In this case, the universal set is the set of letters of the English alphabet. Subtract A to get A complement. That is, U is equal to the set of letters of the English alphabet. So the complement of A is going to be the set of the letter B, C, D, F, G, H, J, K, L, M, N, P, Q, R, S, T, V, W, X, Y, and Z. So I hope this helps you to understand the idea of the complement. So that's it for this video. We're going to move on to the last concept. Is called Cartesian product.